So this is the last of the videos on stacks and queues. And in this video, we're going to talk about implementing a queue using a linked list. Okay, so just like before, we could have derived queue, linked queue from the unordered linked list, but I think as before, it makes more sense to use our queue ADT that we developed in the last video, just to have some consistency among implementations. Okay. So this is not going to be as cumbersome and as convoluted as the array version was, because it's going to be pretty easy to keep track of the front and the rear of the linked list. Okay, using the same techniques that we used when we created the linked list in the last chapter. Okay, so we're going to need two different pointers, though. We're going to need a pointer to the front of the queue and a pointer to the rear of the queue. So initially, there, of course, would be the same one, but as things move, it's going to move back around. Okay. So again, I'm going to use my handy dandy little diagramming here to create an example of how that would work. Okay. So again, we want to reason about how things are going to be before we get to the coding, and we'll go through the code pretty quickly. It should be pretty familiar by now. Okay. So when we create our queue, okay, here's my kind of the instructions I'm working with. I'm going to add an 8 and then a 4 and then a 10. So remember, things are added to the rear of the queue, but then when we use the delete queue, which removes it, it's going to come off the front. Okay. So when we create our first node, same as before, we're going to call it new node. Okay. And don't know what that was all about. So let me grab the right thing here. Okay. So we're going to have a new node will point to this, and we'll just, I don't know what it's doing. It's very strange. Um, I want to create a new one. I want to get to there. I don't know why it's creating something new every time. Super strange. Let me see if there's a way. If I make this bigger, does it help? Give me more room, maybe? Yeah, it's wanting to create, even though I'm not on that. Okay, that's the arrows. That's that. Yeah, I don't know what it's doing. Okay, I must have accidentally thrown something in there. That happens sometimes. Okay, but still let me do what I want. Okay, this should be okay. So what I need to do is delete that. Now we're better. Okay, sorry about that. Okay, so the first we're going to create a new one with 8, and it will initially point to nothing. Okay, and at that point we're going to have both um, queue front and queue rear point to that element. It's the only one we have. Okay, so when we go to add the 4, we're going to add 4 at the rear. Okay, so the queue rear is going to move, the queue front's going to not. So again, I'm not going to go through all the motions, but we're going to create a new node. Okay, we're going to set the values of the new node of 4 there. We're going to change the link so that this points up here. Okay. And then this one will have the backslash. What is this doing? Well, I've made too many videos today. That's what it amounts to. That is the backslash. Okay. And now the queue rear. So queue front link, we're having now point to this node, and queue front continues to point there. Okay. So now we've added our second one. This in the same way, when we go to add the third, again, we create a new node. We're going to put a 10 there. And now this is going to get that. And then we're going to point this one to there. And we're going to move, nope. Going to move Q rear to there. Okay, so Q rear now points to that one. Okay, so that's the basic idea from that. Okay, if we then do a Q delete Q, okay, we're going to want to move. Again, we haven't done this in the graph before, but we're basically going to create a temp pointer. Okay, and that temp pointer is going to point to what we're going to delete. So it's going to point to there. Okay. We're then going to change the Q front to point to there. Okay. We're then going to delete that note, delete temp. Okay. And temp goes away. Okay. And we're left with that. So that's the basic idea of how things are going to work. Okay. So let's take a look at the code. Again, most of this we've seen before in looking at the other videos that we've done. Okay. So let's take a look over at the code. Then we'll run through a sample program. And then that should do it for the instructional material here. Okay. So again, I'm including the QADT, including the IO stream. Not sure if I need it or not. Yeah, I've got a C out somewhere along the way. I don't know if there's an assert or not. I'm gonna go ahead and put it in here, but because if I put it in here, I won't need it. There we go. So again, this is the code from the book. I just typed it over. So again, I have to create my node type here. Okay. It's templated. Okay. It has info and it has a link, a pointer to a node type for a link. Okay. And then we get to the actual class itself. The class linked Q type is derived from, so it's a subclass of the QADT. The QADT is an abstract data type, has some obligations that we have to meet on the different functions that we'll talk about as we go along. Okay. And I'm not sure what that's doing. Weird stuff. Okay. It's a weird stuff day. Anyway, so our public things that we have, we're going to reassign the assignment operator, the equal sign. We've got the is empty, is full, initialize, front, back, add Q, delete Q. Then we have our constructor. We have the copy constructor, and then we have the destructor. Okay. I will say that the book does not give you the destructor. You have to do it yourself. Pretty quick to add. As the book says, it looks very much like the initialize, going through and deleting all the things that were in the queue. Okay. Which I think mostly makes sense. I've got it on here, but I won't dwell on that because I may ask you to do that to make this fully functioning. Okay, so the private data, all we need here, we're going to need two pointers, one to the front of the queue and one to the rear of the queue. Just as we saw before, both these need to happen. Okay. So the is empty queue, pretty straightforward. We're just going to see if queue front is equal to the null pointer. If it is, then we know that we don't have anything. Okay, so it's empty. The same as we had with the stack implementation, linked list, sorry, the linked list implementation of the stack. The is full is never true. Okay, so we just return false there. Okay. Then initializing the queue. Again, there's no guarantee. This is not the constructor. This is if we have an existing queue we want to wipe out. So we're going to have to create this temp pointer. Have to go through and one by one delete off the front of the queue. Okay, by setting each element equal to temp, and then moving the queue front to its link, next one along the line, and then deleting it. Okay. And then finally, when you're done, you set the queue rear equal to the null pointer. Now both front, queue front, queue rear point to null, and you've deleted all the space taken up from all the different nodes. Okay. You then have the add queue. So the add queue is where we're again going to add in a new element of type. Okay. We have the constant here because it's not going to change. So we're going to create the new node like we've done thousands of times, it seems like. Not really. We're going to create some memory for it with the new keyword. Okay. We're then assigning the new element to that, and we're assigning the link of that new node to the null pointer. Okay. Then we're going to check to see if the queue front is equal to null pointer. If it does, that means we have no elements in the queue. Okay, so we're going to go ahead and set the queue front and the queue rear equal to that new node. It's the only node we have. Okay. If not, then we know that we're going to add it at the rear. Okay. Now, in a normal linked list where we didn't have a rear pointer, we would have to search through node by node until we found the one that pointed to null. But we already have that rear pointer, so we can go ahead and add that so that the queue rear link, which would have been null before, is now going to point to our new node. Okay. And then the queue rear is going to move to that new node we just created. Okay. So that's how that's going to work. The front, we do have the assert. Good. So I did need it. Again, if it's not empty, okay, we're going to return the queue front info. The back just returns the queue back info. Again, with the assert, no big deal there. Delete queue. Okay, it's going to go through. And if it's not an empty queue, if it's an empty queue, we're going to say we can't. So again, the delete queue doesn't delete the queue. It deletes the first element of the queue. So something from the front. Okay. So for this one, we're going to set temp equal to that queue front so we can get rid of it. Then the queue front is equal to the queue front link, moves it forward, deletes temp. Okay. And then if the queue front is equal to null pointer, then we're going to make sure that the queue rear also equals null pointer. That's if we deleted the last element. Okay. And if it's not, if it is empty, then we say we can't remove something from an empty queue. Okay. So there's the constructor, it just sets up those pointers, and there's the destructor, which we're not going to look at too much. Okay. So now let's take a look at a test program. Okay. So this one, again, including IOStream, I'm going to include our linked queue.h file. Okay. We're using namespace standard. We have our int main. So this is how we're going to create our new queue. Okay. So we're going to say linked queue type int. We're making a queue of ints. We're going to call it queue. Queue is not a reserved word. Okay. So we have two integers, x and y. We're going to initialize the queue, okay, which sets everything up to 0. We're going to take the variables x and y, give them values. We're going to add those two to the queue. We're then going to let x be equal to the queue front, okay. We add the 20 first, and then we add the 35. So the queue front should leave it at 20, okay. We're then going to delete that first element from the queue, okay. We're then going to add to the queue just some random things, x plus 7, 78, x, y minus 6, doesn't really matter, okay. And we're then going to go through and list out. Is that what we're doing? No, it looks like we're emptying the queue. So while the queue, well, it's not the fact that it's empty, well, it's something there. Oh, we are. We're going to see out the front, then we're going to delete it. Okay. Note that this is destructive. So by the end of the code here, the queue will be gone. Okay. If we wanted to be able to maintain the queue as we're printing it, we would have to make a copy using the copy constructor or the overloaded assignment operator. Okay. So if we run this, it should run pretty quickly. And there's the elements that we have that's doing all those weird little x plus and y minus things. Okay. So that's the basic idea with stacks and queues. So we've talked about in the first video, the basic structure of them, why we have them. These limited access data types are there to enforce certain behaviors. So with the stack, everything that you only deal with the stack from one end. You push things in the top. The last thing you pushed in is the first thing you pop back off. Okay. Where a queue is kind of the opposite, where things come in the back and leave by the front. Either of them can be implemented either as arrays or as a linked list. The linked list in both cases are going to be more efficient from a memory standpoint. Okay. So that's it. The rest of this chapter has quite a large example of using queues for simulations. And it's certainly worth looking through that. I'm not going to ask you to do that, but it will help your understanding to be able to go through that example. So next up, there will be a problem set for this that should be available by the time that you watch this. And if you have any questions on this chapter, make sure you let me know. Okay, we're headed next to, I believe, sorting algorithms. That will be the next topic of discussions for us.